everyone. Today we are gonna look at Fourier series. Okay, Fourier series is very important when you have problems involving sine, cosine, and things like that, especially when you have a periodic function. Okay, so you want to know how this periodic function can be expressed in a form of series. Okay, so this Fourier series expansion is suitable in solving certain classical problem, applied mathematics such as mechanical and acoustic vibration, heat transfer, planetary motion, signal processing, and so on. So we're going to look at some of these, especially some simple problem, how you can solve using Fourier series. Okay, before we know this, we need to know about even and odd function. Okay, even and odd function. Okay, consider, now let's look at a problem f that such that is defined on the interval negative pi to pi. Okay, a function is even, okay, is even if f of minus x equals to f of x, where x in the interval minus pi to pi. On the other hand, we say the function is odd if f of negative x is equals to negative fx, and similarly x in the interval negative pi to pi. Okay, so to understand this, let's consider this problem. For example, we have fx equals to x. Okay, now let's put negative x here. So we have negative x. Now if you look at here, fx is negative fx, so this is equals to negative fx. So we can see that the function is odd. Okay, now let's consider another example. Okay, this is example 1. Let's look at example number 2. Okay, so fx equals to x2. Okay, now let's put f negative x where we have negative x squared. This is x2, which is similar to fx. So my f negative x equals to fx, right? So we say this is even. Okay, let's look at another example. Fx equals to cos x. Now when it's involving cos x, okay, so if you don't know even or odd, what we can do is we can substitute a value here. Okay, let's put fx, x is pi. Okay, for example, f of pi will give me cos pi. Cos pi is negative 1. Okay, now let's find f of negative pi, which is cos negative pi. Now cos negative pi, it happens to be, it is also negative 1. Negative 1. Okay, which is equals to f of pi. If you look at it, f of negative pi equals to f of pi. Therefore, we say this is an even function. Okay. Now, another example will be sine x. Okay. So, fx equals to sine x. Okay, now let's say we want x is pi. So let's find pi over 2. Let's start with pi over 2. Okay, so f of pi over 2 will give me sine pi over 2, which is 1. Now what is f of negative pi over 2? We have sine pi negative pi over 2, which is negative 1. Okay, so look at it. This is actually negative f of pi over 2. This is pi over 2, so negative. So this is an odd function. Okay, so this even and odd function can be very useful when we want to solve some related problem. Okay, so I can say that this x is odd, cos x is even, sin x is odd, and x squared is even function. Okay, and then what we want to look now is how it related with the series. Okay, how it is related to the series. Okay, let's look at Fourier series now. Okay, a Fourier series for an periodic function is given by fx equals to a naught plus summation n equals to 1 to infinity a n cos nx plus b n sin nx. Okay, this is for 2 pi period. Okay, where our coefficient, these are called the Euler formula, and the Fourier coefficient a naught is given by 1 over 2 pi, integrate from minus pi to pi, fx dx, and an equals to 1 over pi, integrate from minus pi to pi, fx cos nx dx for n equals to 1 to and bn is given by 1 over pi from negative pi to pi, fx sin nx dx for n equals to 1 to Now how this is related with the even and odd function? Okay, so if the f function you're given is even, okay, if the f function is even, what happened? For example, fx is even, then we have our bn equals to 0. This bn here will equals to 0. Okay, and what happened to my an? Okay, so we will have a naught will become 1 over pi 0 to pi fx dx. Okay, so if my f function is even, okay, we will have my a naught, this a naught here will become like that, and then my an will become 2 over pi 0 to pi fx cos nx. Okay, nx. X. So, but however, if let's say my fx is odd, what happened if fx is odd? We will have an will become 0. Okay, so what left will be, so we need to find our a naught, but fx will become summation n equals to 1 to infinity bn sine nx. Okay, so I hope you can get this. Okay, so this equation here. So this is the changes happen if we have odd and even function. Okay, so let's see, we have time to look at one example. Okay, let's look at one example here. Okay, so let's look at one example. The example is given by, find the Fourier series of fx equals to absolute value of x, where x in the interval from minus pi to pi. Okay, so we want to find the Fourier series of t. If you look at this graph here, this graph of x, okay, this is graph of modulus x. Okay, this is graph of fx equals to x. So is it odd or even function? Okay, let's check whether it's odd or even. So if I put negative x here, we have same. Okay, when I put a negative value, you get the same back. Where you get back fx. So f of negative f give you back fx. So we know that this is even. Okay, now my f is even. Okay, so what has happened if fx is even? Automatically we know that bn equals to 0. Okay, we know bn equals 0. Now all we want to find is to find an. Find a naught and an. Okay, a naught is given by, okay, I have let's write the series first. The series of fx for this thing is given by fx equals to a naught plus summation n equals to 1 to infinity an cos nx. Okay, since bn is 0, so we have this one. Now what is a naught? A naught equals to 1 over 2 pi minus pi to pi fx dx, which is 1 over 2 pi minus pi to pi. But we know that this is even function. Therefore, with even function, our integral become 1 over pi 0 to pi x dx. Okay, so I hope you're with me. So now we have to integrate this interval here. So we have x2 over 2 from 0 to pi. So this will leave you with pi squared over 2 minus 0, which is pi over 2. Okay, now an on the other hand is given by 1 over pi from minus pi to pi fx cos nx dx. Okay, so we don't have time to solve this, but we know that if I put the interval, we have 1 over pi minus pi to pi modulus x cos nx dx. Now we know that this is even and this is even. So if you have even and even function, it will give me an even function. Okay, so I can write this as 2 over pi 0 to pi x cos nx dx. Okay, so all you gotta do is solve this interval. That's all.